1/15 of a teaspoon. That's how much water the average single interaction with ChatGPT uses, according to Sam Altman, the boss of OpenAI. So if you type, "Can you help me solve this maths problem?" That's a drop. Or, "Can I put lime instead of lemon in this recipe?" That's a drop. Or, "Why is the sky blue? Help me write this email. Help me improve my website code." Mr. Altman claims there are 1 billion messages sent to ChatGPT every day. And ChatGPT is just one AI bot. Chuck and Gemini, DeepSeek, Claude, and others, it's clear that the AI revolution is a thirsty one. Striking though it is, some experts are more than a little skeptical of Sam Altman's estimate on water usage. At this point, there was just not enough information for me to agree with or trust the number. Their number was perhaps referring to some tiny models. We're considering a medium-sized, large-length model. That's the size of GPT-3. Basically, 111, if you write an email or ask some questions, if you have 10 to 50 queries, you're going to, 116, be consuming roughly 500 milliliters of water. This calculation includes water used in cooling and electricity generation. The BBC asked OpenAI for more details about Sam Altman's estimate, but the company declined. Either way, it's clear, AI uses a lot of water. But why? Every time you send a prompt to an AI, it has to run complex calculations to understand and respond. This work is done by the most powerful and specialized computer chips in the world, housed inside enormous data centers. Even before users can send prompts, the training process for the models uses the chips to carry out intense work. And all that extra power means the hardware can overheat and become damaged if not cooled properly. Most data centers use air cooling systems, which was fine until AI came along. But now, because these data centers and the infrastructure that's going in is so much more energy intensive, there are liquid cooling approaches that are now being implemented. For liquid cooling, the water must be clean to prevent bacteria growing or clogs and corrosion in the system, which means using mostly drinking water. Here's how the most common liquid cooling process works. It begins by piping coolant over the processing chips within the servers. This cooling liquid absorbs the heat and takes it away from the electrics to a heat exchange unit. Water is used to reduce the temperature of the coolant. The coolant then recirculates back to cool the servers. Meanwhile, the now hot water is piped to cooling towers, where a combination of fans and water vapor dissipate the heat, cooling the water. Some of the water evaporates in that process, while the rest is recirculated through the process several times before being discharged back into the nearby water source. Overall, up to 80% of the water evaporates.